And welcome to Backspace Academy, and welcome to the AWS Certified Associate course. In this, our very first lecture in the course, I'm going to talk at a very high level and brief perspective about AWS. So this is going to be simply an introduction to AWS. I'm not going to go into any specific detail about any of those services, because this is a very big course and it's going to cover a lot of areas, and we're going to talk in quite in-depth detail about all of the AWS services and offerings later on through the course. But the purpose of this lecture is just to give you a very brief overview of what cloud computing and AWS is all about. I'm going to start off with a discussion about the global infrastructure of AWS and how big it is and how it all works. And then I'll lead into cloud computing. What does the cloud mean? And what are the different cloud computing models that are available to us? I'll discuss the concept of serverless computing and the different models that are available to deploy into the cloud. Then I'll have a look at the different categories of services that are available within Amazon Web Services. And I'll talk about the services within those categories that are relevant to this course. And those include compute services, storage, database, networking and content delivery, management tools, security, identity and compliance, messaging, and finally analytics services. The AWS global infrastructure is massive. It consists of 16 regions located across the globe, 42 availability zones, and well over 50 edge locations. Now, your choice of region can depend on a number of things. For example, you may want to give your end user the best user experience by having the most optimized latency. For example, if you're located in Brazil, then you would probably want to use the São Paulo region, because that's going to give your end users the best or most optimized latency to access your infrastructure. But that said, there may be other reasons why you want to use a different region other than the region that you are located in. For example, I'm located in Australia, in the Sydney region, but I mostly use the US East 1 or US East Standard region. The reason for that is that that region has significantly lower cost for me than the Sydney region. So not all regions cost the same amount. They do vary according to region. Another reason for me to use the US East Standard region is that I know that that region fully supports the broad offering of AWS. Whereas if I'm looking at something like the Mumbai region, which is a brand new region, that doesn't support all of the AWS services. So a lot of times you can get stuck if you're developing a solution and then you get to implement that solution, you find out, oh, hang on, my Mumbai solution actually won't work because we don't have that service available within Mumbai. So you need to take that into consideration, and that's why throughout this course we use the US East Standard region predominantly. You may also want to locate your servers in a specific region based on regulatory or legal requirements. There may be a requirement that you have to have your servers located in your country, and for that perspective you may want to consider locating them within your country, or there may be the opposite, that may be a regulatory requirement that requires that you have to locate your servers outside of your country. So the choice of region is quite important, and there are a number of factors around that. All regions are divided up into availability zones. Some have more availability zones than others. For example, the US East regions have 3. And when we look at Mumbai, for example, that only has 2 availability zones. It's a smaller region and a newer region. So those availability zones within a region, they are insulated from failures in other availability zones. So what that does, it enables you to have very good high availability. It's good for disaster recovery, because if one of those availability zones goes down, If you have your infrastructure shared across those availability zones, the infrastructure that is located in the other availability zone will continue to operate. So it gives you good redundancy and reliability for your infrastructure. And a lot of services out of the box support multi-availability deployment. For example, the relational database service does that very well. We also have 50 or well over 50 edge locations, and they are for the CloudFront service. Now, what CloudFront is, it's a caching service for Amazon Web Services, and it gets your content, your regularly used content, in a CloudFront distribution, and it locates it specifically at these edge locations. So what that means is that you are going to get really high performance delivery of your content through to your end user. It's also going to save you server costs, because that content that is regularly accessed and doesn't change that much will be delivered immediately to your end user and won't even go anywhere near your servers unless that changes. So the CloudFront caching of data is a very important and very useful feature of AWS as well. Now, before we get too far ahead and start discussing all about Amazon Web Services, I think we need to ask the question, what is cloud computing? What is this whole cloud thing all about? And if you ask that question to a number of people, they generally get stumped if they haven't thought about that answer. And they'll generally come back and say, well, the cloud, it's internet. The cloud is the internet. It's that interweb thingy, which is not necessarily correct. Well, it's actually not correct. So I think one of the best definitions for cloud computing comes from Wikipedia. And that simply says that cloud computing, it provides shared computing processing resources and data to computers and other devices on demand. So Amazon Web Services has a massive amount of computer processing resources located across the globe, and databases and data storage, and that is available to computers and other devices on demand when needed. And it is shared across all of those literally millions of users. And by doing that, the costs involved in using these IT resources is significantly reduced because it's shared across millions of people. AWS also has its own definition of cloud computing, which is similar but slightly different. Cloud computing is the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. So it's pretty well the same definition, but it mentions that it goes through a cloud services platform with pay-as-you-go pricing. And that is very good if you're talking about AWS or Azure or any one of these commercial cloud offerings, but it doesn't really explain a private cloud. So you can actually create your own private cloud using your own pool of resources, and you don't need to actually use a AWS or any other service provider to do that. So that's really what cloud computing is all about, and it's not just the internet. Cloud computing is where we pull together computing resources and share those resources on an on-demand basis to multiple users. There are a number of models available for cloud computing, and they vary from very low level and nuts and bolts models right through to very high level and abstract models. Now, the first one there, the low level nuts and bolts model, is the infrastructure as a service, and that contains the basic building blocks for cloud IT. So we're going to grab these basic building blocks and we're going to piece them all together and link them all up, and we're going to create a solution. And a good example of that is the AWS Virtual Private Cloud that creates a virtual private cloud and all of the routing and so forth within that, and the security within that. We can also have the Elastic Compute Cloud, or EC2, where we can create Linux servers or Windows servers or whatever servers we want to create, and we can launch them within our VPC. And we also have elastic block storage, which is storage that we can attach to our EC2 instances. So we can use this to piece together an end solution. And so don't be too concerned about whether you don't understand what VPC, EC2 and EBS is. We're going to discuss this further on in this lecture and in very much more detail throughout the course as well. The next model is the Platform as a Service, or PaaS, and that is where AWS manages the underlying infrastructure, which is usually the hardware and operating system. A good example of that is where you want to deploy a database, for example. So you could use the EC2 service and create a building block using EC2 inside of VPC and have an EBS attached to it and whatever. And then you can put your application, your database application on top of that server, and you manage that server, you manage that operating system, you manage that database. Or you could use something like the RDS, Platform as a Service. So the Relational Database Service, or RDS, that will take care of the basic building blocks. It'll take care of the Linux operating system. It'll take care of the EC2 instances. And you really just need to worry about the database itself. And so that's a step above from using EC2 to manually create a database solution. Another example is Elastic MapReduce, which is AWS's Hadoop platform as a service, and AWS Elasticsearch, which is AWS's Elastic.co Elasticsearch platform as a service as well. The next one is far more abstract, and that is software as a service. And that is where a completed product that is run and managed by the service provider, and mostly refers to end user applications. So there's some example of that if you are using web-based email, where you go to a browser and you access your email. That is a software as a service. You don't need to worry about what's behind that. You just use it as a service. Another very good example of a software as a service is Microsoft Office 365. Another one is Salesforce.com, where you can use these applications and use them as a service and deploy them as a service without having to worry about what is behind those, not having to worry about the architecture and the operating systems and all of that behind these services. Another concept that we need to talk about is serverless computing, and that allows us to build and run applications and services without thinking about servers at all. And that kind of sits somewhere between platform as a service and software as a service. So although it is quite abstract and high level, you still can create an application on top of that. So it's not fully a software as a service, it fits somewhere in between there. And it's also referred to as a function as a service, or abstracted services. Some good examples of that are the Amazon Simple Storage Service, and we'll talk more about these services in the next few slides. AWS Lambda, which is a service where we can just give our code to AWS and it will run that code for us and bill us in 100 millisecond increments. So we don't need to worry about anything other than just supply our application code and Lambda will run that for us. Amazon DynamoDB is a serverless computing NoSQL database. We just create a table for that database and AWS looks after everything that is needed to run that database for us, and it worries about everything for that database and the support of that database. Amazon Simple Notification Service is another serverless environment where we can send messages to different devices. We can send push notifications to mobile devices, and we don't need to worry about what's behind that SNS service. There are a number of cloud computing deployment models, depending on whether we want to deploy 100% to the cloud or whether we want to take advantage of existing on-premises infrastructure as well. So the first one there is a fully cloud deployment, and that's where everything is fully deployed in the cloud and all parts of the application run in the cloud. We have a hybrid solutions where that is connecting the infrastructure and applications between cloud-based resources and our existing resources that are not located in the cloud. We also have an on-premises solution, which 100% on-premises we're not going to be discussing other than here in regards to the AWS certified exam. And that is where we have 100% of our cloud computing deployed on our own infrastructure. So that is deploying resources on premises using virtualization and resource management tools. And that is where we call a private cloud, where we use our own resources, we pool all those resources together, and we use a virtualization model to create our own cloud computing on-premises private cloud. Now, if you go to the AWS homepage at aws.amazon.com, and you should already have gone to that homepage and should have already have created an AWS account. But if you go back to that homepage, you can see, if you click on products, you'll see that the offering available from AWS is absolutely enormous. And when you're not exposed previously to AWS and you look at it, you think, wow, where do we start? So we're just going to run through the different categories there, and we can see that the categories are divided into compute, storage, database, and a whole heap of other different categories. We're just going to go through those categories now and look at some of the services that we'll be using within those categories within the course. The categories that I'm going to concentrate in this lecture are the compute, storage, database, networking and content delivery, management tools, security, identity and compliance, messaging, and the analytics category. Now, there's a lot more. So we've also got, on the right hand side there, you can see we've got application services, we've got migration, we've got developer tools, mobile services, Internet of Things, business productivity, desktop and app streaming, game development, artificial intelligence, and that list is growing all the time. But I'm just going to concentrate on those categories on the left that are most relevant for an associate level certification. The compute services are all about running code. So the first one there is the Elastic Compute Cloud, or EC2, and that is where we can deploy a virtual server. And that virtual server could be a Linux server, it could be a Windows server, it could be a server that contains an operating system such as Linux plus an application, for example, a WordPress application. And we treat this server in the way that we would any normal Linux server, and we apply updates to it, we configure firewall settings and all of that sort of thing as we would do normally. The next thing that we can look at is the Elastic Container Service, and that takes EC2 a little bit of a step further, and what that does is it allows us to deploy Docker containers, and those Docker containers will package up into a container everything that is needed for that server to be deployed. So it'll have the operating system, it'll have the WordPress application, it'll have your actual application on that as well. And you can package that up and deploy that as a container to a server. And that provides some advantages because, for example, if we're using EC2 on its own and then we deploy our application on top of EC2, if our EC2 Linux operating system gets upgraded, there may be interoperability problems between the new operating system and our application. And we may not be aware of those until it's too late, until it impacts our end user. So it may be an advantage for us to package everything as a container, as a Docker container, and make sure that our operating system and our application, everything are working offline before we deploy it to our EC2 servers. And that's where ECS comes in. This is not a course on Docker, by the way. If you want to learn more about Docker, the best place to go is docker.com, and they have a training website there at training.docker.com, which is a very good site if you want to learn more about Docker, but you don't need to know Docker to pass the AWS certified exam. If we have multiple EC2 instances, we're going to need to have a way of distributing requests to those EC2 instances and making sure that the load on those EC2 instances is balanced so that one doesn't do more work than the other, and you're going to get a pretty even latency to your end user when they make a request to your infrastructure. And that is where an elastic load balancer comes in, and that will provide an endpoint for requests to come into your infrastructure, and those requests will be distributed through to your EC2 instances. The next thing to look at is auto scaling. So this is where elasticity comes in. So if we get hit by a peak in demand, and demand is never consistent, or very rarely is demand a consistent thing. So at 9 o'clock in the morning, people come to work and they switch their computer on, and you have a demand there. And so auto scaling can help accommodate that by launching more EC2 instances when demand increases, and making sure that latency is kept under control. So the next one there is Lambda. And Lambda is a serverless environment. So we just provide Lambda, our code, as a Lambda function, and AWS runs that code for us on demand when we need to. And it bills us in 100 millisecond increments. So we don't need to worry about anything. What's behind that? It's a serverless environment, and we can reduce costs because when that service is not being used, AWS doesn't bill us for it. The last one there is Elastic Beanstalk, and that is a deployment service for compute resources. So we could manually create EC2 servers. We can put them inside an auto scaling group and define that, and we can have it all distributed, requests distributed through an elastic load balancer and define all that. Or we could use Elastic Beanstalk, and what it will do is it will automatically create and deploy all of those resources that we need to create a compute environment. And all we need to do for that is to supply it with our code, our application code, and it will deploy everything that we need to be able to create a highly available and scalable solution for compute capacity. So let's have a look at how a web server application could be set up using some of these compute building blocks. So as we can see there, we've got our AWS cloud, and we can create within that AWS cloud a VPC, or virtual private cloud. And that VPC is our own personal and private space within the AWS cloud. And no one can have access to our VPC unless we grant them permissions to do so. So within our VPC, we can launch servers in the form of EC2 instances. So those EC2 instances, they would have a copy of the operating system. For example, if it was Linux, it would have a copy of our development environment being, for example, Node.js, and our application would be all on those EC2 instances. And we could also look at deploying Docker containers using the ECS service if we would like to, and that would contain as a container the operating system, our development environment, and our application all in one. So once we've got our server there deployed, we need to think about how we're going to manage peaks and troughs in demand. For example, if someone comes in at 9 o'clock in the morning, they switch their computer on, there's going to be a short-term demand. And how are we going to manage that demand and make sure that we still have good latency for our end user? And that's where an auto-scaling group will come in. And so we can use our EC2 instance that we've created. We can create an image of that, and we can use that as a launch configuration for our auto-scaling group. And so our auto-scaling group, when demand is increased and it receives a signal to increase its number of EC2 instances, it will launch more EC2 instances. And this is what we call horizontal scaling, as opposed to vertical scaling. And vertical scaling is not something that you should be doing, and that is where you would tear down your EC2 instance and you would replace it with a bigger instance, because it's not an elastic solution as such. So horizontal scaling is what we want to do. We want to add more instances horizontally, and then as demand decreases, we want to be able to reduce the number of instances that are available. Now that we have multiple server instances, we need a way of directing our traffic to those instances, and also making sure that the load on those instances is balanced so that one is not working more than the other, and we're going to get consistent latency across all of these requests. So our requests are going to come in from outside the AWS into our elastic load balancer. And our elastic load balancer will then distribute those requests across the multiple EC2 instances depending on which one has the least amount of work on it. So it will provide the best latency solution for routing those requests. Now, this is a very simplified solution, and there's certainly, if you were going to make a real solution, there'd be a lot of other things that you would need to consider, but this is really just as a high level example of how you would use these building blocks of the compute resources. AWS has a very large number of storage options available, but for the AWS Certified Associate level exams, we just need to be concerned about a few of them, and just need to know that the others exist, but you don't need to be an expert on those. The first one there being Simple Storage Service, or S3, and that is one of the serverless servers. It's a very abstract service. And with Amazon S3, we create something called a bucket. And we can drop objects into that bucket. And those objects could be documents, they could be files, they could be videos, it doesn't really matter. But it's a very abstract service where we create this thing called a bucket, and we put our objects inside of that bucket, and we don't need to worry too much about what's behind that. And we don't need to worry too much about scalability and elasticity and that sort of thing. Amazon looks after that for us. The next offering there is AWS Glacier, which is a long-term archiving and storage solution. And that provides the lowest cost storage on AWS, and it is great for storing and archiving large amounts of data. But it is not suitable for data that needs to be accessed on any sort of regular basis, because it's going to take 3 to 4 hours to access that data, and you're going to incur significant costs if you need to access that data. But we could have a solution where we would use Amazon S3, for example, for our regularly accessed data. And as that data becomes less current and not being used anymore, but needs to be archived for maybe for compliance purposes, we can set up a rule that over a certain amount of time can archive that data over to long-term storage in Amazon Glacier. The next service there is EBS, or Elastic Block Storage. And that allows us to attach storage, block storage, to EC2 instances. And that is very similar to basically putting a disk drive inside your desktop computer. In the same way, you can put block storage and mount that block storage to an EC2 instance. And in the same way that you can't attach more than one computer to a disk drive, it's the same with EC2 instances and EBS block storage. You cannot attach multiple instances to a single EBS volume. So if you want to have storage that is mounted on your EC2 instance and is accessed as a drive, you need to look at network attached storage. And just the same as in your computer at home, you might go out and buy a NAS and plug it into your Ethernet, and you have network attached storage. And EFS, or Elastic File Service, is network attached storage. And you can create a mount point that you can mount to your EC2 instances, and they will have access to EFS in the same way that it would have access to an EBS block storage. The next thing there is Amazon Storage Gateway, and that is where we can interface our on-premises infrastructure to, or data that's located on premises, to data that's located on AWS, or data that is located in different locations within AWS, and we can set up a storage gateway job that can manage the transfer of that data between those two different systems or different areas of AWS. And finally there we've got the AWS Import Export Snowball, and this is very good from a deployment perspective. So if you're looking to deploy from an on-premises solution through to an AWS solution, and you've got petabytes of data, you want to deploy a data warehouse, for example, it's going to take a very long time to deploy that using the internet, and it's going to cost you a lot of money. So what AWS can do is they can send you out a Snowball device, and you can upload your petabytes of data to that Snowball device. Then you can courier that back to AWS, and they will upload it into one of their storage solutions, for example, Amazon S3. So let's have a look at a storage example. So again, we've got our AWS cloud, and we create our virtual private cloud, our own little private space within that AWS cloud. And we launch some EC2 server instances inside that VPC. So those EC2 instances would have root storage, so they would have their operating system located on that, but you may want to have an extra drive attached to that for storing of data, for example. And so that's where you would attach an Amazon EBS or Elastic Block storage to that EC2 instance. And as stated previously, we can only attach that to one EC2 instance at a time. We can put multiple EBS volumes on an EC2 instance, but we cannot attach an EBS volume to multiple EC2 instances, in the same way that you can't do that with the disk drives on your desktop computer at home. So the other solution there is that if we want to have a drive that is mounted to our EC2 instance, that is access to or by multiple EC2 instances, that's where our Elastic File Service system will come into effect, and that's our network attached storage, or NAS storage solution on AWS. So we would create an EFS mount target for our EC2 instances, and that would mount that EFS share onto our EC2 instances, and we could mount that across multiple EC2 instances, as we can see there. So we've got our EFS share, and that's located outside of our VPC, and we have our EFS mount targets that are located inside our VPC that provide access through to that EFS share. And then we look at accessing the Amazon S3 service. Now the Amazon S3 service is not located inside our VPC. That's located inside AWS, but outside of our virtual private cloud. So normally for an EC2 instance or an EC2 server to access Amazon S3, it needs specific permissions to do that. But there is also another way that it can do, is that we can create an endpoint, an S3 endpoint, for our virtual private cloud that can create a route for our EC2 instances to access the Amazon S3 service. And so our EC2 instances will go through that endpoint there at the edge of our VPC, and they'll be able to access our S3 bucket, and they'll be able to put objects inside of that bucket and take objects out of that bucket. And then over time, when objects within that bucket become obsolete, or they become not accessed very regularly, then those objects can be transferred over as an archive to Amazon Glacier. And that is our long-term storage solution. But again, Glacier, very, very low cost per gigabyte or petabyte or whatever, but it provides a very slow solution if you need to access that data. It takes about 3 to 4 hours to get that data back out again. So let's have a look at a different example now. So it's a hybrid storage example. So we're going to take advantage of not only the AWS cloud storage solutions, but also we're going to combine that with our own on-site storage located in our own corporate data center. So first of all, when we deploy this solution there, where we want to synchronize our data between the corporate data center and the AWS cloud, there's going to be a very large amount of data to be transferred across to the AWS cloud when we first deploy this solution. So that's where the import-export Snowball would come in, and where you would get a Snowball device delivered to you from AWS, and you would upload your data from your on-site storage into your Snowball device, and then you would send that off back to AWS via courier or whatever, and they would then upload that through to your, when they receive it, they would upload that to your Amazon S3 bucket. So once that data, the bulk of that data is across into the AWS cloud, then you need to look at maintaining that and synchronizing the data between the corporate data center and the AWS cloud. And you do that over a virtual private network, or you can do that over a direct connection between your corporate data center and the AWS cloud, a high-speed direct connection if you'd like. But the transfer of that data is managed using the AWS storage gateway, which orchestrates a lot of that stuff that needs to happen when you're synchronizing data or you're transferring data from one location to the other. In the database category, we have first off there the Relational Database Service, or RDS, and that provides database platform as a service, and that's for a number of database engines including Oracle, Microsoft SQL Server, MySQL and variants of MySQL including MariaDB and PostgreSQL, and that list is changing regularly, so make sure that you have a look at the RDS section of the AWS website and see whether any new engines have come up. There is also Amazon Aurora, which is AWS's enterprise scale version of MySQL, and that is optimized for the cloud, for AWS. There is DynamoDB, which is a serverless NoSQL solution for a database, and that is unique to AWS. You won't see DynamoDB on any other platform other than AWS. We also have Amazon Redshift, which is AWS's data warehousing solution, and that is for storage and access of petabytes of data, and that is based upon the PostgreSQL database engine. Additional to databases, we have a caching solution with Elasticache, and that enables us to put regularly accessed data from our databases inside a cache and locate that cache in front of our database. And by doing that, that allows that high-speed in-memory response to request directly from a cache for data that is regularly accessed. Now, there are currently two caching engines, including Redis and Memcached for the Elasticache service. And finally there we've got the AWS Database Migration Service, which simplifies and orchestrates the migration of one database to another. So a very quick database example here. So I've got AWS on the left and I've got a on-premises corporate data center on the right. And so we've got a on-site database there that we want to synchronize with Amazon RDS there, or I've just got here an Oracle database. It could be anything that we want basically. But it is a synchronizing service, and it could be for disaster recovery or whatever. So what we've got there is that we have a link between the corporate data center and the AWS cloud. That could be through a virtual private network. It could be through a direct connection to the AWS cloud. And then we have a database migration workflow job. And that will orchestrate the transfer of data from the on-site database through to our RDS service located on AWS. To enable high-speed access to our regularly used data, or to reduce the load on our RDS instance, if we're having requests that are coming to our database there, we can put an Elasticache node in front of our database. And so anything there that is regularly accessed will be stored in that Elasticache node, and it will be responded to in memory back as a request to whoever has requested it. If it's not in the cache, then it will be forwarded back to RDS and then forwarded on after that. And so that provides a very good solution to reduce those overheads and at the same time increase the performance of your delivery of data. In the network and content delivery category, we have first there the virtual private cloud, or VPC. As we explained previously, that is creating our own private space within the AWS cloud, and that is restricted. People cannot access our VPC unless we grant permission for them to access it. And we can launch services inside of our VPC. We can launch servers such as EC2. We can launch RDS instances or databases within our VPC and take advantage of the secure environment that our VPC offers. There is also AWS CloudFront, and as we explained previously, that provides caching of our regularly used content, and it delivers that cached data or that cached content to well over 50 edge locations across the globe and provides very high speed access to our data that is regularly accessed. We also have Route 53, which is AWS's domain name service, which allows us to have our own custom domain name and route our traffic through to or from our domain through to our infrastructure. We also have the AWS Direct Connect, and that is a very high speed connection between our on-premises infrastructure and AWS. So we can have a very high speed fiber optic connection to that without having to go through the internet to access our AWS resources. And that's very important for large enterprises that need to have high speed access to their resources. And of course, we've already talked about ELB, which is also part of the compute category as well as the networking and content delivery category. So let's have a look at a networking example. I'm just going to pull some of these nuts and bolts and bits and pieces together to create a solution. So first of all, we have there the AWS cloud, and the AWS cloud, as we mentioned before, is divided up into regions. And within those regions, we have multiple availability zones, and those availability zones are isolated from each other. And that provides a big advantage for us, because if, for whatever reason, an availability zone goes down, if we have our infrastructure shared across multiple availability zones, we will still continue to operate. Because, for example, there we've got 4 EC2 servers. If one availability zone goes down, the other 2 can still operate and respond to requests. Now we could take that one step further, and we could put that inside of an auto-scaling group with health checks. And so if those instances in the availability zone that has gone down have failed their health checks, then what will happen is that the other availability zone will end up having 4 instances to take up the slack there. And those again will be distributed through an elastic load balancer as we explained previously. And so that's a very good, highly available and fault tolerant solution. And in the course, we'll be going through a lot of this sort of thing, and we'll be doing solutions like this, and we'll become quite competent at doing this on our own from first principles. So if we want to reduce the load on our EC2 servers, and we also want to be able to provide very high speed access to regularly accessed content, we can put a CloudFront distribution there, which will take a copy of regularly accessed data or regularly accessed information from our back end, and it will deliver that through to many, well over 50 edge locations across the globe. And that's going to reduce that load on our elastic load balancer and the EC2 instances underneath that. It's going to provide very high speed access, low latency access, and it's going to also reduce our costs significantly by doing that. If we have a domain there, I've got the example.com. If we want to direct traffic from that domain through to our infrastructure, we can use the Amazon Route 53 domain name service to do that, and that will route our traffic through to AWS CloudFront. And if that information that is being looked for is not located in the CloudFront distribution, or if it's dynamic data that is changing quite regularly, then that will go through CloudFront and on back into the back end, and then come back in through to Route 53 and be delivered back to the end user. If it's content that's regularly accessed and located in the CloudFront distribution, it will just be delivered directly from the CloudFront distribution. We also have there on the right hand side a corporate data center, and if we wanted to link up our corporate data center to our AWS account and access those resources with quite high speed, we may not want to go through the wider internet and come back in again to access our resources. We want to go directly through there with high speed. Then we can look at setting up an AWS Direct Connect connection, which will be a high-speed fiber optic connection between our corporate data center and the AWS cloud. In the management tools category, one of the tools that we'll be using quite a bit will be CloudFormation, especially if we are a SysOps administrator or a developer. And what CloudFormation does is that you can write a JSON document or a YAML document, effectively a text file, and you can define exactly what your architecture should be. So you can define a virtual private cloud, you can define EC2 instances and all this sort of stuff, and you can define that in a file. And then the CloudFormation service will grab that CloudFormation template, it will create a CloudFormation stack which will deploy all of those services for you automatically. The big advantage of that is that because we are now defining all of our infrastructure in a JSON or a YAML document, we can use Git or any other version control system to manage that document. And all of a sudden our infrastructure will be treated in the same manner as we treat our code. And so if we want to make an update, we update our YAML or our JSON CloudFormation template, and we redeploy our infrastructure. If we have any issues, we can go back to a previous version and roll that back if we have any problems. So it's very similar to what you would do when you're developing software and rolling out updates to software. You can do the same thing with your infrastructure. Another area that we're going to be using quite a bit, or another tool that we'll be using, is CloudWatch, and that provides monitoring of our services. For example, if we have a server, we could monitor the performance of that server, and we could give off alarms that would alert us to problems if that server goes down or if that server becomes overloaded. We can also use CloudWatch alarms to trigger an event for an auto scaling group. So if the EC2 instances are getting overloaded within an auto scaling group, then CloudWatch can send an alarm to the auto scaling group to launch more instances. And we can also set low set points for CloudWatch, so where the demand on these EC2 instances, for example, goes below a certain level, then we can also use that to trigger an alarm for an auto scaling group to reduce the number of EC2 instances we have. We also have OpsWorks, and that is another deployment tool like CloudFormation, but it uses chef recipes. It doesn't use a JSON template, it uses chef recipes for deployment of that infrastructure. You don't need to be an expert in chef for the AWS Certified Associate course, but if you want to learn about chef, go to learn.chef.io, and there's some very good resources there on that. But again, you don't need to know chef to pass the AWS Certified Associate exam. You just need to know the basics of OpsWorks and understand that chef is what is driving that. We also have CloudTrail, and that is a really good service for security and auditing perspectives. What that does is that it continuously monitors all of the API calls in our infrastructure. So for example, if we have a situation where we have an attack that has come through our firewall, or if we have an attack that has come from within our infrastructure from, for example, a rogue employee, we can continuously monitor what is going on. So anything that happens in the AWS console, for example, if you launch an EC2 instance using the AWS console user interface, that will send an API call to AWS for that to happen, and that will be picked up by CloudTrail. So if you find that something suspicious is happening, you can react to that, and you can also you can integrate that with CloudWatch, so that it can provide alarms that can alert you to any security issues that may have occurred. Also, after an event, if you want to look at what happened after a security event occurred, you can look at the CloudTrail logs and see exactly what happened. Another management tool there is the Trusted Advisor, which is an expert system provided by AWS, and what it does, it will run a scan of your existing infrastructure and it will advise you on things to change. It will advise you on areas of performance. It will advise you on areas of costs. It will advise you, of course, on areas of security. And if you go through and use Trusted Advisor, it's a very good tool because there might be something that you haven't picked up on, and then you can take corrective action to close that gap. In the messaging category, we have Simple Queue Service, or SQS, and that is a serverless service for decoupling our applications from demand. What I mean by that is, for example, if we have an application that is processing messages or whatever it's doing, we can use a Simple Queue Service as a queue in front of our application. So if that application all of a sudden receives a massive amount of demand, those requests for processing will go into the queue, and they will be built up in the queue until such time as our processing server is able to process that and reduce the queue size. So it's effectively decoupling our application from the demand by putting a queue in front of it, just the same as you would have a queue at the shopping centre or a queue at your local bank. The same concept. The next one there is Simple Notification Service, and that provides publish and subscribe messaging. And the way it works is that you would create a SNS topic and you would publish a message to that SNS topic. And anyone who is subscribed to that topic will receive that message. It can also be used for mobile push notifications. For example, if you would like to send from your application push notifications to an iPhone or to Android devices, you can do that through the SNS service. And finally, there we have the Simple Email Service, which, as the name says, is for providing bulk delivery of email. So let's have a look at a process decoupling example. So on the right there, we've got some instances. And so those instances are processing messages as they come in. Now, if we have a situation where we have a massive spike in demand and we have a whole heap of messages coming in at once, then that will most likely crash our EC2 servers, which is something that we don't want to happen. So to decouple the demand from our process, we can put an SQS queue in front of those EC2 instances. So what that will do is that the messages will come in, and if there's a big spike of messages coming in, they will just build up into the queue until such time as the EC2 instances, they can just go through and process those. And the way they would do that is that the EC2 instances would poll the queue to see if there are any messages in the queue, and it will process those messages, and then after it's finished processing that message, it will delete it from the queue. And so all of a sudden we can handle these irregularities in our demand without crashing our EC2 instances. But that said, that is not really a perfect solution, because we could have a situation where we just didn't have enough capacity in our processing instances to handle the average demand. And when we have a situation like that, the SQS queue will just grow and grow and grow indefinitely into such point that the SQS queue becomes overloaded and crashes. So we don't want that to happen. So what we can do is we can use an auto-scaling group, and we can launch our instances within an auto-scaling group, and we can have a CloudWatch metric from the CloudWatch service that can trigger an alarm to scale out or scale in. To scale out by adding instances to increase our processing capacity, or scale in by reducing instances and reducing our processing capacity. And by doing that, we are going to have an optimized solution, an optimized from performance and optimized from cost as well. So the way we would do that is that we could set up a CloudWatch metric that would be based upon the length of the SQS queue. So if we get to a point where the SQS queue builds up too much, then we can have an alarm that triggers an auto-scaling event to scale out and add instances to our auto-scaling group. But at the same time, we don't want too many instances when the demand goes down. So we can set a lower set point that will trigger a CloudWatch alarm when the queue is empty for a significant amount of time, and then we can set that to as an alarm to the auto-scaling group, and the auto-scaling group will reduce the number of instances. So that way we are not only managing spikes of demand, we are also matching from a long-term perspective the performance of our instances and the capacity of our process. We're matching that really very well to our demand, and it's going to give us the best performance and the lowest cost solution. Now that said, what happens if, for example, we've made an update to our application code and it has a bug in it and it's not processing those messages properly? In a situation like that, it doesn't matter how many instances we add, the SQS queue will still continue to grow because the messages just aren't being processed because there's a bug in the application code. So we can set an even higher set point in our CloudWatch metric. So when the SQS queue gets really high, we can have that send an email notification to our administrator, and we can use the SNS service to do that. It will send a notification as an email, and then our administrator can come in and investigate the problem. And so that's what we talk about with a process decoupling service or a process decoupling architecture, and it's quite common that we would use something like that with AWS. Now, the most important category of all being the security, identity, and compliance. The main one there is the Identity and Access Management Service, or IAM, and that is how we manage access to our AWS account. So we automatically, when we create an AWS account, we have a login for our AWS account, being a root login. So that provides unlimited access to our AWS account, and we don't want to use that. So what we do is we create different users that can access our AWS account, and we have fine-grained control around the permissions that they have within our AWS account. So we can create multiple users with different levels of permissions. We could have a general user, or we could have an administrator user. We could have a finance user that would only have access to our finance area. And we can do that all using our Identity and Access Management Service. We can also group these users into IAM groups. And we can also have roles that can be used by EC2 servers that can allow them to access different areas of our AWS account. The next service there is the AWS Directory Service, and that looks after authentication of third parties that want to access our AWS account. For example, you might have a mobile application that has millions of users, and those users need to upload files to Amazon S3 or something like that. Now, that's not going to be practical to do. You're not going to be able to create millions of users using identity and access management. It's just not going to be able to be done. And even if it was able to be done, it wouldn't be practical at all. So the AWS Directory Service can use, for example, AWS Cognito, and that will provide an authentication service, and that can be integrated with other authentication services such as Facebook or Google. And so we can authenticate our users based upon that, and then the directory service will manage the permissions that are defined for that. We could also use the AWS Directory Service as a service for Microsoft Active Directory as well, and we can use it for linking between third-party LDAP directory services as well. The next one there is the Certificate Manager, and that enables us to be able to create SSL certificates so that we can have HTTPS encrypted traffic to and from our websites. And we also have the Encryption Key Management Service, or KMS, and that is a secure service for managing our encryption keys that we use for encrypting our data that may be in data stores, or could be in S3 or whatever, and we can use those encryption keys and make sure that they're safe by using the KMS service. And finally there we've got the Web Application Firewall, or WAF. Now that is a firewall layer that we can put in front of our infrastructure. And that is additional to the firewall settings that we would set up in, for example, our Linux operating system, and also additional to our EC2 security groups, which are also similar to a firewall. So this is an additional layer of defense that we can use for our applications. The last category that I want to talk about is the analytics category, and the areas that we need to understand for a associate level certification is AWS Elastic MapReduce, or EMR, and that is AWS's Hadoop as a service. And Hadoop is an analytics service for analyzing large amounts of data. If you want to learn more about Hadoop, just go to hadoop.apache.org and you'll learn all about Hadoop. You don't need to be any particular knowledge of Hadoop for an associate certification. You just need to know the basics around Elastic MapReduce and understand that Hadoop is operating to make that happen. And we'll talk more about that later in the course. We have Elasticsearch, and that is the Elastic.co's Elasticsearch application, which has been provided on AWS as a service, and that gives you search engine capabilities for your applications. We have Amazon Kinesis, which is a very rapidly growing service, and that enables us to collect real-time data as streams and analyze that also in real time, which is really quite powerful, especially when you start talking about things that, such as internet connected devices and Internet of Things applications, where you're collecting a large amount of data on a real-time basis, and you may want to have access to that data in real time. Amazon QuickSight, which again can integrate with Kinesis to provide data visualization, and it can also be used with static data. If you've got data in, for example, an S3 bucket, you can visualize that data using Amazon QuickSight, and it's very similar to the way you would use Tableau, or if you're a Java programmer, the way you would use BERT for visualizing of data. But it's a very good enterprise scale solution that provides a really high quality service at around about, well less than half the price of an equivalent commercial service. And finally there we've got the data pipeline, and that allows us to process and move data between different applications, and it orchestrates a lot of this stuff for us. And behind that is clusters of compute capacity that make that happen. Now again, one thing to consider here is that the AWS service offering is rapidly expanding, and it's always a good idea to check the availability of a service in your particular region. For this course, we use the US East 1 standard region, simply because that is the main service that has the broadest range of AWS services available to it. If you're using, for example, Mumbai, that's a very new service, and so it's not going to have all of the services available for it. But if you just go to that URL there that is on the screen, and you can check the availability of a service in a region before you start working on your application. So that brings us to the end of a very, very long lecture. And you have covered a massive amount of information in a very short amount of time. So if your head's spinning right now and you didn't quite get all of it, don't be too concerned, because from now we're going to go through and really understand all of these services in a very in-depth manner. So I don't know about you, but I'm exhausted. So I suggest that we take a break, and I'll see you in the next section.